Hey there, hi there, ho there, welcome to Unit 10, Surface Water. Living in Arizona, this is something we're not used to thinking about, seeing, experiencing. So let's dive into this, shall we? So some of you might think, well, yeah, Arizona's pretty dry. Well, yeah, but there are still plenty of surface water areas in the state. Numerous large rivers. For instance, we have the Salt River, the Gila River, the Colorado River, some large lakes, mostly created by reservoirs, Lake Mead, Lake Powell, etc. This little blue spot is Lake Pleasant right here, right on the Agua Fria, just north of Phoenix, the Roosevelt Lake. So there's a number of waterways and water features in Arizona. Most people don't think of that. So let's talk about the hydrologic or water cycle. And the reason being because that's the third cycle in geology that goes to shape the earth, that plays a part in geology. We talked about the tectonic cycle, we talked about the rock cycle. Now we're getting into the hydrologic cycle and everything involved. Surface water, this unit, groundwater, next unit, glaciers and deserts unit, after that. Because the water cycle or hydrologic cycle has such a big part to play in the rock cycle, meaning it has a big part to play in geology. So to break down a few things about hydrology, first is the scientific study of water. A hydrologist studies water and the movement thereof. And the hydrologic cycle, or the water cycle, is a model that describes the movement of water on and in the earth, above, on, and in the earth. The hydrologic cycle itself is driven primarily by the energy from the sun. That's what drives the water cycle. So here is a quick little diagram of the water cycle or hydrologic cycle. However you want to say it. Hydrologic cycle is just a fancy word for water cycle. So it starts with the sun. The sun, for instance, heats up the ocean. That water evaporates, goes into the atmosphere, cools and condenses, creates clouds, which could create precipitation in the form of rain, snow, sleet, hail, etc. That precipitation makes its way back to the ground. Now, either the water infiltrates and soaks into the ground, or either evaporates back up into the atmosphere from surface water, or transpires. That's water evaporating from plants, essentially, back into the atmosphere. So either it goes back into the atmosphere to begin this smaller mini cycle, or it infiltrates into the ground, which eventually all water flows to the ocean, and then the process starts all over again. I'm not going to dive into the definitions too much. It's just kind of unnecessary. You know what? This is kind of a shorter section. Let's just keep on trucking, shall we? Let's go ahead and jump into section 2. But before we do, let me give you the first part of the super secret code. It is the number 8. You got me? The number 8. So, that was a hydrologic cycle. So, water on Earth. This is not a trick question. Where is most of the water on Earth? Blue in this image equals water. So where is most of it? Not a trick question. The oceans. All right. Obviously, most of the water is in the oceans. The Atlantic Ocean, Pacific Ocean, Indian Ocean, Arctic Ocean, Southern Ocean. Most of Earth's water is in the ocean. How much so? 96.5% of Earth's water is in the ocean, which leaves about 2.5% fresh water and 1% other saline or other saltwater features. Okay, so most of Earth's water is in the oceans. All right, fresh water only makes up a little sliver of the total of Earth's water, only 2.5%. So where is most of Earth's fresh water? Where is most of Earth's fresh water? That's non-salt water. Well, let's break it down. So let's take fresh water and break that 2.5% down. So of that 2.5% of the Earth's total water, 68.7% of that 2.5% is glaciers and ice caps. So most of the world's fresh water is frozen, glaciers and ice caps, which we'll talk about in a later unit. 30.1% of that is groundwater, which we'll talk about next unit, leaving only 1.2% of 2.5% to be surface or other fresh water. Most people say, oh, most of Earth's fresh water is like rivers or lakes, like the Great Lakes. Nope. Excuse me. It's frozen. And if it ain't frozen, it's below ground. And then whatever's left, that's the stuff on the surface. That's why water is such a precious commodity. There's just not a lot of it we can access. And so if we go ahead and break down that surface water, the fresh water, of that 1.2%, 69% is ground ice and or permafrost. That's water kind of frozen in the upper layers soil of the earth. 20.9% of 1.2% of 2.5% is lakes. And you can see there's also some in the atmosphere, rivers, swamps and marshes, soil moisture, as well as living things, a little slice of living things. So if we were to visualize this, okay, let's say if we were to take Earth's water, hold on a second. Thereabout. Let's say all of Earth's water fit into 100-liter bottles. If all of Earth's water fit into 100-liter bottles, 97.5 of those would be salt water, because there's 96.5% oceans, and then another 1% saline water. So 97.5 liters of salt water, leaving only 2.5 liters fresh water. Of that 2.5 liters, 1.72 liters is frozen. 0.75 liters is groundwater, which only leaves 0.03 liters of surface water, which is about 6 teaspoons full. So if all of Earth's water was 100 liters, 6 teaspoons, that's 2 tablespoons. 2 tablespoons of water is fresh water. And that includes water in the biosphere and all the plants and living organisms, as well as in the atmosphere. Water is a precious commodity, and there's just not a lot of it. So doing all those percentages, again, 97.5% is salt water, 2.5% is fresh water. Of that, 1.72% is frozen, glaciers and permafrost. 0.75% groundwater, much of it inaccessible. 0.3% surface water, lakes, rivers, atmosphere. And if we break down surface water, excuse me, 0.02% of that is permafrost, frozen soil. 0.007% of that is lakes, rivers, swamps, and marshes. 0.001% is soil. And 0.0009% is the water in the atmosphere. And then 0.00008% is the amount of water in all living things. Again, what I'm trying to say is there's not a lot of fresh water to go around. Most of it's frozen or deep underground, inaccessible. So only a small percentage of Earth's water, about 0.03%, is even usable to animals and plants. This is from surface water and a fraction of groundwater. Some surface water and a fraction of groundwater. About 0.03% of all of Earth's water is the only water that's usable. Now, we can do things like desalinate ocean water, meaning we take out the salt, but that's energy intensive. We need to boil it and heat it and distill out all the salt and put it through different filters to clean out the water. But that's all energy intensive, fossil fuel burning. So as far as raw, just regular old fresh water, only 0.03% of the Earth's water is fresh water usable to living organisms. It's not a lot. And it's only going to get worse. As glaciers melt, a lot of that fresh water is going into the oceans. As the atmosphere warms up, a lot of surface water, lakes, rivers, swamps, marshes are evaporating. If water is a concern, which is probably the number one concern in Phoenix, if not all of Arizona, that Phoenix, if not all of Arizona, is not the place you want to live in 10, 15, 20 years. You're going to want to live someplace that has water, that has access to fresh water. Good times. We'll pause there. When we come back, we'll kind of break down surface water, looking at streams and other features. I'll see you back here in just a second.